Are we going?
Yep.
Okay. Any quadratic equation is going to have this basic shape. This is called a parabola. Okay, they're going to come in a lot of shapes and sizes, but they have that basic shape. Some of them open up, some of them open down. All right. What I'm driving for is quadratic equations are going to have the form ax squared plus bx plus c equals 0. You have two solutions if you count them right. Okay? Now, they're not necessarily real, they're not necessarily distinct, but you will have two solutions. And basically today we're looking at different methods of solving quadratic equations. Now, the first example I have for you is 5x squared plus 2x plus 3 equals 4x squared plus 6x minus 1. Your first job is to get the things equal to 0. Okay, you can't do much of nothing until you get it equal to 0. So, if you add negative 4x squared to both sides, you get x squared. Add negative 6x to both sides, you get minus 4x. Add 1 to both sides, you get 4. And we get 0. Now, your first best method for solving quadratic equations is factoring. Okay? This guy will factor. It factors into x minus 2, 20 squared equals 0. So in this case, we get one solution, even though I just said we get 2 on all of these, right? Technically, this is a second degree polynomial, which means you're going to have 2 solutions. This is said to have multiplicity 2. And if you look at a graph of it, a graph of this is going to look something like this, where this is the point 2, 0. Okay? And what happens here is kind of special. This thing is said to have a multiplicity 2. It comes down, kisses the x-axis, goes back up again. Okay? So even power multiplicities are going to bounce. You with me? Alright, now, another example is x squared minus 4x plus 4 equals negative 49. Well, sometimes you get quadratic equations that look like this, and the easiest way of solving this one is to recognize that the left-hand side factors into a perfect square. That's the same thing as x minus 2 20 squared. Still equal to a negative 49, yes? Okay, now, there is a property of equations that says that if you have like x squared equals k, you can solve that by taking the square root of both sides. And we have that situation here. Now, y'all are used to taking just the principal root. Until now, when we said, what's the square root of 16? We said 4, right? Nothing in the world wrong with that, except it's technically what? Plus and minus 4, isn't it? Yes? Now, because quadratic equations have 2 solutions, you have to put the plus or minus there. In other words, if x squared equals k, x is plus or minus the square root of k. So we can do that here. This gives you the square root of this is x minus 2. The square root of 49 is going to be plus or minus the square root of negative 49. So we get that x is minus 2 equals plus or minus 7i. Isolate x, you get x is equal to 2 plus or minus 7i. Be aware that's 2 solutions, x plus 7i, or 2 plus 7i, and 2 minus 7i. Go with me? And in the software, you have to type them in twice. Go with me? In the software, you have to type in 2 plus 7i in one box, 2 minus 7i in the other box. But for me, on exams and quizzes, that's good enough. Okay? Alright, now, if it's not something that looks like this, something that's easy to factor, you can force it to do this. And that's how we come up with the quadratic formula. This is called completing the square. Now granted, you're never going to have to be walking down the aisles of a grocery store and have to complete the square on quadratic to get out the door of the grocery store. Alright, but this does have its uses in later in higher math. For example, in the calculus, there are certain integrals you can't do unless you can complete the square on the exponent. Okay, so on the next exam, on the next quiz, I'm liable to ask you to solve a quadratic equation by completing the square. Alright? Now, 5-step procedure on your handout on how to do it. We're going to run an example real quick. First example I have for you is 2x squared plus 12x minus 10 equals 10. Now, if you look at this, actually that is page 2. The first step is to divide by A and move C to the other side. And what I'm talking about when I say that, I'm talking about a quadratic equation in general form. X squared plus bx plus c equals 0. Alright? So the 10 on the other side, technically you're supposed to move it to the left-hand side, but we're not going to worry about that since we're going to move everything over there anyway. But what's really important here is you have to divide by the coefficient of x squared. You have to make the coefficient of x squared into 1. Because if you don't, everything you do from then on out is junk. Alright? So, I'm going to write x squared plus 6x minus 5 equals 5. Dividing that equation by 2. Move c to the other side or get x squared plus 6x by itself. So we get x squared plus 6x equals 10. Yes? Okay. Now, next step is to find your L. L is going to be half of this number. In this case, L is half of 6. And I always want you to write down what L is. Half of 6 is 3. Okay? I think I used K in the handout, but K, L, same thing. Are you with me? Alright, now, this example is pretty simple because you're going to see something here in a minute that's easy to factor. They're not always easy to factor. Are you with me? That's why you write down what L is, because
half a B.
Half of B, all right? Actually, half of B over A. It's half of this number. After you make the coefficient of this 1, it's going to be half of that. All right? Now, so if L is 3, L squared is going to be 3 squared, which is 9. You want to add L squared to both sides. That gives you x squared plus 6x plus 9 equals 9 plus 10. All right? This is what I'm saying. This one's pretty simple. I expect every single one of you to look at x squared plus 6x plus 9 and tell me that factors into x plus 3 squared. All right? But sometimes you're going to have fractions here. Okay? You're going to have letters here. It's not always easy to recognize. That's why you write down what L is. Now, if this had been negative 6, my L would be a negative 3. L squared would still be positive 9. You with me? But this would factor, well, this factors in what? X plus 3 squared. X plus L squared. If L is negative, it's going to be X minus L. And that's equal to 19. Yes? Now, take the square root of both sides. Take the square root of x plus 3 squared, I get x plus 3 equals plus and minus the square root of 19. Isolate x, get x equals negative 3 plus and minus the square root of 19. Yes, sir?
So you get x squared plus 6 equals 10. You take half of 6
Right.
and square it and add it to both sides.
Exactly what you do. All right, there.
Is it half
Half of this number.
B over A?
That would be over A. You stop and think about it, 6 is 12 divided by 2, B over A. Okay? Basically, you take half of this number after you make this coefficient 1. Okay? Officially, that's going to be half of B over A.
Oh,
1 half B over
but sometimes the A might
A.
one
If A is 1,
over
it
the-
doesn't matter.
If it's not 1, like sometimes like
Remember, your first step is to make the coefficient of x squared 1.
1.
Okay?
Yeah.
All right. All right, now, next, I'm going to derive the quadratic formula for you. Completing the square has its uses, but that's kind of hard. We don't do that every single time. All right? If you look at the general quadratic, ax squared plus bx plus c equals 0. Folks, that is every single possible quadratic equation, okay? If we can solve it, we solve them all. All right, now, before I go on, I should point out to you that in this homework, when you do your homework on the computer tonight, it's going to say, solve this using the quadratic formula, solve this by completing the square, solve this by factoring, all right? The computer has no way of knowing how you did it. I have no way of knowing how you do your homework. Y'all with me? I would recommend that you do it the way the computer says to do it. That way you practice in all the methods. Okay? Because on exam or quiz, what we're doing in this unit really is doing the same thing, we're just doing it different ways. Okay? When we do that, then on exams or quizzes, I'm liable to say solve by factoring or solve by completing the square. And if you want any credit whatsoever, you have to show me the work that goes along with that method. Y'all with me? If I said solve this by completing the square, you throw it in the quadratic formula, you don't get any points. Y'all with me? All right, now, to derive the quadratic formula, that's what I'm fixing to do here. So I want to derive it for you because I'm a firm believer if you see where formulas come from, it's easier for you to remember. Quadratic formula is about the most important formula we do all semester. All right, so I want to show you where it comes from. Now, this generally pops up as a bonus question on the final. All right, so first step, divide by a, move c to the other side. Yes? So I'm going to write x squared plus b over ax equals negative c over a. Okay, divided by a, move c to the other side. Then we find our L. L is going to be 1/2 of this number. In this case, my number is b over a, which turns into b over 2a. Okay? Add L squared to both sides. Well, L squared is going to be b over 2a quantity squared. That turns into b squared over 4a squared. So I want to add that to both sides. So we get x squared plus b over ax plus b squared over 4a squared equals b squared over 4a squared minus c over a. Go with me. Okay, now, like I was saying a while ago, this is why you write down what L is. The whole reason why you're doing this is so you know how to factor this. I wouldn't expect a single one of you to look at this and tell me it factors into x plus b over 2a quantity squared unless you did this procedure. Go with me? You're making it factor into x plus L. L is b over 2a quantity squared. That's the whole purpose. All right? Now, let's look at the right-hand side. What do you got to have to add or subtract fractions?
4a.
Common denominator. Right? The least common denominator between 4a squared and a is 4a squared. Yes? I've already got a denominator of 4a squared here, so I just write b squared on top. Looking at the denominator of a, I'm missing what? 4a. So I'm going to multiply this by 4a over 4a. If you think about it, you're just multiplying by 1 in a clever fashion, right? The top turns into a negative 4ac, c, and the bottom is 4a squared. Yes? Go with me? All right, now, take the square root of both sides. Take the square root of this, the square goes away, you get x plus b over 2a equals plus and minus. Can't forget that plus and minus. The square root of the top is b squared minus 4ac divided by the square root of 4a squared. Okay? Now, because you have terms under this radical, there's not a whole lot you can do with that. All right? But on this radical, you have factors, don't you? You can take roots across multiplication, you can't take roots across addition or subtraction. So what we have, to take this across the equal sign, we get x equals negative b over 2a plus and minus the square root of b squared minus 4ac. The square root of 4a squared is 2a. Yes? Okay? That's the quadratic formula. Generally, you see it written as x equals negative b plus and minus the square root of b squared minus 4ac divided by 2a. Okay? Folks, y'all need to pull a George Strait thing on this and write this down. Make a tape recording of it, stick it under your pillow at night. Do whatever it takes to know that formula. This bad boy is so important that in 5 years, I'm going to drive through your hometown, I'm going to look you up. I'm going to ask you what the quadratic formula is. If you can't tell me, I'm going to lower your grade a letter. All right? Yes, sir.
I was reminding you, Trip, playing you, if you sing it like with the Gilligan's Island thing, it's really easy to remember.
Yeah, that works too. I do have a very terrible song on the internet I could play for you, but I don't have time for that. All right? You with me? Main thing is know this formula and know how to use it. Okay? Let's look at an example problem. 2x squared plus 8x minus 3 equals 3x. All right? First off, you got to get it in general form. You got to get it equal to 0. So I'm going to write this as 2x squared. 8x minus 3x gives me 5x minus 3 equals 0. So for this example, A is 2, B is 5, C is negative 3. Okay? Remember, in this course, the majority of your credit comes from the right numbers and the right formula in the right place, yes? In other words, your very first step here, or second step I guess, would be x equals negative 5 plus and minus the square root of 5 squared minus 4 times 2 times negative 3 all over 2 times 2. Okay? And folks, in this chapter, make sure you show me that step. I know y'all know that 5 squared is 25. I know y'all know that 2 times 2 is 4. Show me that step. Y'all with me? If this is a 5-point test problem, that's going to be about 3 of your points right there. All right? And I'm not joking. Okay? Y'all with me? And then from there, just do the arithmetic. And another kicker is, you have to make sure you recognize that you have a negative times a negative under the radical, which gives you a positive. Yes? So this turns into negative 5 plus and minus the square root of 25. Negative 4 times 2 is negative 8. Negative 8 times 3 gives you a positive 24 over 4. Yes? Okay? Now, I picked one that we could have factored. Didn't say anything about that at the start, but if you look at 2x squared plus 5x minus 3, run the AC method on it. 2 times negative 3 is negative 6. 2 factors is 6. It's subtracted 5, or 6 and 1. It will factor, which means we're going to have rational solutions. You know with me? It's not something like this where you have irrational solutions. All right? Or imaginary. Okay? Now, 25 plus 24 is what?
49.
49. Square root of 49 is?
7.
7. So this turns into negative 5 plus and minus 7 over 4. And basically with these, you keep going until you can't go anymore. Because we have rational numbers, we can keep going on this. Y'all with me? Alright, so negative 5 plus 7 is 2. So we get x equals 2 over 4, or x equals negative 5 minus 7 is negative 12 over 4. Well, that turns into 1/2 and -3, doesn't it? Yes?
Yeah.
Okay? All right, now, what's the title of this course? College algebra. It's not physics, okay? But we do a little bit of physics in here. We're going to start today. We're going to talk about gravity. We're going to talk about free-falling bodies. Have any of y'all ever been parachuting? Bungee jumping? Been bungee jumping? Why? Not for me. I'd weigh too much to tie my fat butt onto a piece of rubber and jump off a bridge. But if you go bungee jumping, if you go parachuting, if you drop something, if you throw something up, this formula affects those bodies, okay? If you jump out of an airplane with or without a parachute, hopefully you have one, this formula ought to be first and foremost on your mind, because this is what controls how fast you're falling. Go with me? Okay, until you open the parachute. This formula does not take air resistance into account. When you open the parachute, when you hit the end of the bungee cord, then this formula goes out the window. Go with me? If you had a window. All right? Now, but my point here is your height from ground level, or whatever you're considering to be the ground, is going to be negative gt squared over 2 plus v sub naught t plus h sub naught. Now, because this is algebra and not physics, I will give you that formula. You don't have to memorize it. All right? And we're going to talk about what all these letters mean here in a second. Go with me? Okay? Now, but don't worry about memorizing those. You do need to memorize the values for g, though. All right? Now, h of t, height as a function of time. It tells you the height at any given time t. T is your time in seconds, because if you're falling, seconds are what matter. Go with me? If minutes or hours matter, you've got more to worry about in this formula. All right? Go with me?
Again, h. H is h. What is h?
H is your height, the distance from ground level. Okay? G is the force due to gravity. For most of our problems in this course, the force due to gravity at or near the surface of the earth is 32 feet per second squared, or 9.8 meters per second squared. Okay? That does vary a little bit. If you want to weigh a little bit less, move to Denver. It's not going to make a whole lot of difference, but if you want to gain some weight, move to Houston. All right? Or New Orleans. New Orleans, you're below sea level. You weigh even more in New Orleans than you would in Houston. But anyway, T is your time in seconds. V sub naught, or V sub 0, is your original or your starting velocity. Original or starting velocity. Okay? H sub 0, or H sub naught, is your original height from ground level. All right? Go with me? Now,
So is h or not the same as the h over
No.
t?
H naught is a fixed number. This H is going to be changing as time goes on.
Okay.
It's gonna be feet on the
Feet
second-
or meters, whatever it happens to be.
And what's h or not again?
The original height from ground level.
Okay.
Okay? Let's look at this example. I mean, no offense to bungee jumpers, but
What is HO exactly?
the original height, how high you are from ground level when you start.
How are you saying that?
H sub naught.
H,
Naught.
h naught or h to the naught?
H naught. H sub 0.
Okay.
Okay? I mean, it's an old-fashioned term, means 0. All right. All right, Lisa, an experienced nut job and bungee jumper, leaps from a tall bridge and falls towards the sharp rocks below. The bridge is 200 feet above the water, or the sharp rocks. Okay, so we know that this distance is 200 feet. That's your h sub naught, your h0, your original height. Okay, go with me? Then you got Lisa up here on the bridge, fixing to jump off, yes? Her bungee cord is 135 feet long, unstretched. Okay, when will Lisa's cord begin to stretch? Okay, in other words, when does she hit the end of her cord? Go with me? Now, when you see the word when in a problem like this, you need to be thinking, all right, I'm looking for a time. Okay, go with me? One variation will give you a time and say, at what time will the distance or the height be this? Go with me? Okay, now, so the first thing you got to do is write your formula. H of T. Now, when you're writing your formula, the first thing on your mind ought to be, what value do I use for G? What units were you given? Feet. So what value we use for G?
32.
Over S squared.
2s, 2t. So we have negative 32 over 2t squared plus.
Is it negative because she's going down?
Uh-huh. Original velocity. When you read this problem, do you see any units given to you as distance over time? No. And what's happening here is Elisa's just basically, she's not really jumping up off the bridge. We're not taking that into account. She's just kind of falling off. Go with me? And when you went bungee jumping, did you jump up or
We're
did
not
you?
allowed to. Yeah,
Not
but
allowed to?
just step off.
Step or fall face forward. So is the cord in your back?
Well, there's like a harness around your waist, but yeah, the cord goes around your back.
All right, but the point here is the original velocity is 0. Yes? Okay. What's the original height? 200, isn't it? Yes?
So since there's not a velocity in there, you put 0.
Okay, go with me? So there's our formula. Simplifying that, this turns into negative 16t squared plus 200. That describes her motion for the first 135 feet. When she hits the end of the cord, this goes out the window. You with me? This cord starts dragging on her, and then she's going to hit the end of the cord, or the end of the stretch. She's going to bounce up, and then up and down, up and down. You've got to use another function to describe that motion that we won't talk about in this class. You with me? All right, now, when will her cord begin to stretch? Here's another kicker to this problem.
When?
Her cord begins to stretch when she's 135 feet from the bridge, yes?
Yeah.
Okay. This function gives you the height at any time t from the ground. Not from the bridge, from the ground. Go with me? So if from here to here is 200 feet, and here to here is 135, how far is it from there to there? 65. Yes? So what we do here is we set this equal to 65. Go with me here. Okay? And the nice thing about it is when your original velocity is 0, you got a neat little shortcut you can take. Because you can use square root property. Most of these, if you have an original velocity, you have to use quadratic formula. You don't have to, but that's generally the best way. All right, so if I add negative 200 to both sides, I get negative 135 equals negative 16t squared. Dividing both sides by negative 16, we get 135 over 16 equals t squared, yes? Go with me? All right, now, you're not asked for t squared, you're asked for t. So t is officially plus or minus the square root of 135 over the square root of 16. Yes? Okay? Now, this problem asks us to round to the nearest hundred, right? And most people right here just punch this into their calculator, which is fine when they say round to the nearest hundred. I want to show you what I'd expect if this is a quiz problem and I don't give you the words round to the nearest whatever. Are you with me? Because remember, if you don't see the words round to the nearest whatever, your answer should be a fraction in lowest terms, yes? All right, so 135, I know I can divide by 5. 5 going 13 two times, that gives me 27. 27 is 3 to the third. So the prime factorization of 135 is 3 to the third times 5, yes?
Yeah.
Which means a square root of dividing all the exponents by 2, so a 3 is going to come out. I'm left with 3 times 5, or 15 on the inside. Square root of 16 is 4, yes?
All those plus, there's no minuses.
Thank you. I was fixing to ask, does anybody notice what's wrong here? I dropped the plus and minus, didn't I?
Yeah, but it's, definitely gonna be plus, because it's a time. No minus time.
A lot of times, you're going to get answers to physical problems that make sense mathematically, but that don't make sense physically. Okay? Example of that in this case is negative time. Negative time here doesn't really make a lot of sense, does it? Are you with me? Okay? So,
No.
don't forget to put your units on your answers. Should be seconds. Okay? As far as getting a decimal approximation, y'all can do that. Just get your calculator out, punch that in, you'll get a decimal approximation. Okay? You with me here? All right. Got another one here for you. If you look at part B, a lot of times students have problems with these rock problems. In the software, you're going to get goofy drawing of a guy standing on a cliff throwing a rock off. Something like that. If you look at this problem, it says a rock is thrown upward with a velocity of 20 meters per second. Okay? So we're leaving the ground at 20 meters per second. From the top of a 24-meter high cliff, when will the rock be 7 meters from the ground below? Okay? And also they say to round your answer to the nearest tenth. Okay, you with me? So, once again, remember, I will give you this formula. H of t is negative gt squared over 2 plus v sub naught t plus a sub naught. Now, first question. What value do I use for g?
9.8.
9.8, because my units were given to me in meters, yes? It's going to be a negative 9.8 t squared over 2 plus, do you have original velocity?
20 meters per second.
20 meters per second. You need to recognize that as being a velocity. Anytime you're given a number with the units or some unit of distance divided by some unit of time, that is a speed or velocity in some shape, form, or fashion. You with me? So this is going to be plus 20t plus what? What's the original height? 24 meters. Yes? All right, this simplifies to negative 4.9 t squared plus 20t plus 24. That gives us the height of this rock at any given time t. Yes? You with me? Now, they want to know, when is the rock 7 meters from the ground? Yes? Remember, this gives you the measurement from where? From the ground, yes? So, to finish this problem, we're going to say that 7 equals negative 4.9 t squared plus 20t plus 24. Yes? No.
Sorry.
What?
I don't know why it's going on.
Y'all with me here?
Again,
Okay, 7 meters from the ground, yes?
yep,
Okay, that's where the 7's coming from. All right, now you have a quadratic equation, yes?
yeah,
Solve it, first step is get it equal to 0, isn't it?
yeah,
So we're going to say that 0 is equal to negative 4.9 t squared plus 20t. 24 minus 7 is what? 17?
yeah,
Yes?
yes,
All right, now, I hate it when the lead term on a quadratic equation is negative. It just messes everything up. It messes up your factoring, it'll mess up your quadratic formula. So, when you have a negative here, get rid of it. Okay? How do you do that? You multiply by negative 1. This is the same thing as 0 equals 4.9 t squared minus 20t minus 17. Yes? Okay? Now, we're ready for the quadratic formula. Now we can say that t is equal to negative of negative 20 plus and minus negative 20 squared minus 4 times 4.9 times negative 17 over 2 times 4.9.
All you did was multiply by negative 1, right?
Yes. Okay? And once again, I know y'all know that negative of negative 20 is 20. And you probably stop and think about it. 2 times 4.9 is 9.8. We already did that arithmetic a minute ago, didn't we? Okay? And you probably know that negative 20 squared is 400. But once again, show me that step in this chapter. Make sure you show me that step. After we get out of this chapter, you can start taking some shortcuts. You can start writing 20. You can start writing 9.8, that kind of thing. Y'all with me?
yeah,
All right, but this turns into 20 plus and minus the square root of 400. It's also important to recognize that here you have a negative times a negative. Gives you a positive, yes? Okay. Another big clue is, guys, you're working a physical problem, right? You start seeing imaginary answers, you probably messed up somewhere down the road.
yeah.
Y'all with me? Okay. Right about here is where I need a calculator. It's important to recognize that you're going to have a plus between those two terms and under the right. Now, if you take 4 times 4.9 times 7, you get 137.2.
Isn't it 17?
Hmm?
Don't you multiply by 17?
Yeah, you do. Thank you. I'm about to make a mistake in front of the world. 4 times 4.9 times 17 is 333.2 over 9.8. Yes? Okay, now, once you show me that step, I'm not too picky about what you show me after that. All right? 400 plus 333.2 is going to be 733.2. You want the square root of that? Square root of that is going to be 27.077666607, and so on. Yes?
Yeah.
They said to round to the nearest tenth, didn't they? Yes? In intermediate steps, you want to go 1 decimal point past that. So I'm going to write 20 plus and minus 27.08 over 9.8. Y'all with me? All right, now, if you stop and think about it, 20 minus 27 is negative, isn't it?
Yeah.
So we can chunk that. So this turns into 20 plus 2708 over 9.8. All right, plus 20 divided by 9.8. That gives us 4.8 seconds. Are with me? Are with me here? Okay? Any questions over this, or this unit,
So it takes him 4.8 seconds
to get to 7 meters
to get to 7 meters
from the ground?
before he dies.
Well, it's a rock. Okay? And you're gonna see several variations of this problem in your homework tonight. You might get the flaming arrow shot from a stage or that kind of thing. All right, but it's basically the same problem. Okay?